I'm Erik Salo. I run products and markets for VDURA. VDURA stands for Velocity Meets Durability, and we're reinventing how people think of high performance storage. I'm delighted to be joined by Mr. Matt Ritter. And Matt, could you please introduce yourself?
Thanks for having me, Erik. I'm the VP of Engineering and Product at SourceCode. I came from the acquisition of Silicon Mechanics back in 2018, and I've been the GM of Silicon Mechanics since 2017.
Excellent. Well, we're really excited about our partnership. Could you tell me a little bit about SourceCode and your full end-to-end solution strategy?
Yeah, absolutely. So SourceCode is technology neutral or vendor agnostic. Pick your favorite term there. The mandate is always to pick the best tool for the job. So we take an engineering-led holistic approach to designing AI and HPC solutions. It doesn't make sense to build a state-of-the-art compute environment and attach it to a legacy NAS or a 10 gig network, but we see that happen over and over. So our goal is always to deliver the best end-to-end solution that we can design that achieves the customer success criteria in the most efficient way possible. Could you maybe speak on how AI is changing data infrastructure?
Oh, it's such a great question. And it's something that we've spent a ton of time trying to understand how to help our customers through. You think about it, in some ways, AI feels brand new, right? It feels like a year or two ago, none of us were thinking about it. And all of a sudden, now it's just taken over the world faster than anything I've ever seen in my career, ever. That's one way. On the other hand, kind of the machine learning world, where you essentially use computers to mine through big bunches of data to find useful stuff. That's actually pretty, that's been happening for decades, right? For a long time.
Sure.
And, so there's this transition now. And that's the really interesting part. It's like, how do you create products that help your customers to serve, tomorrow's workload as opposed to yesterday's? And I'd say, if I don't want to get too geeky, but if I kind of go right down into the technology, the big difference is in the files and the users. If you look at the traditional HPC, I'm going to call it that, so there's a lot of machine learning in that word, but those are kind of large files. You're doing checkpointing primarily with the high performance layer. And you have big files. It kind of looks like a sequential workload, and there's relatively few files compared to these new workloads with all these vectors. They have billions, sometimes even trillions of files in these systems, right? So a huge number of files. They're very small, right? So your workload looks a lot more random than sequential. And of course, the other thing is the users, there's so much innovation going on. It's not a mature space at all. So users are just doing all kinds of crazy stuff. And what they need from the storage layers, they need flexibility, right? And so, that's one of the things that we've really taken care to do is that, VDURA's solution uniquely, you can add capacity nodes, which are really cost efficient, or you can add performance nodes, which are really fast, all flash nodes with our true, parallel file system, right? We're one of the original parallel file systems. You can add those independently. You don't have to decide up front. And that's one of the really big values of the system. The other thing that we do is that we keep all this data under a single namespace, single control plane, single data plane. And so, one of the big challenges is they have all these different tiers of storage, right? So they have the fast tier, and they've got the capacity tier, they got some tier in the middle, and each tier actually works just fine. But then you have to move the data between them, and that is a pain in the neck, right? That's something that really that's really difficult. It's slow in a lot of cases. It's fiddly. And so the thing that VDURA offers is that all this data can live under the same control plane, same system. And that's a real benefit to users.
That's great. Yeah, I like how you explain kind of the differences between AI and HPC. I think a lot of times when we look at the Venn diagram of the two, people are starting to see them as a single circle. But even on the network, there's different considerations. Obviously, in storage, there's different considerations. So,
yeah, they're like I always think the workloads are not siblings, but they're cousins, right? They're not exactly the same, but they're close. Now, could you tell me a little bit? I know you've got this Atlas AI cluster that you guys have been working on a solution. Can you tell us about that and what you're hearing from customers?
Absolutely. So Atlas comes in two flavors. We have the Atlas AI cluster, which is a superpod-like AI factory, and Atlas AI Ignite, which is a scalable entry-level AI factory that can grow from POC to production. So Atlas AI cluster leverages the AI 1200H platform for compute. It comes with either 128 or 208 Grace Hopper 200 GPUs per rack, and it's completely direct liquid cooled. So what's cool about the Evidence solution, unlike most DLC solutions, which target only high TDP components and still require significant air cooling, the AI 1200H actually runs DLC to every component in the rack, asterisk, other than the redundant water pumps. Ignite takes a building block approach to build an affordable AI factory. So its basic level of compute is a Dell XE9680, which is an 8-way HGX system running NVIDIA H200s. And Ignite comes default as air-cooled, but we are able to deploy a liquid-cooled variant as well. So both Atlas AI solutions are networked using high-speed Ethernet or InfiniBand, which plays very nicely with the V5000 data platform. And of course, both leverage VDURA's V5000 data platform for their storage needs.
Oh, that's really cool. Can you tell me a little bit more about the cooling and energy efficiency? It's a really interesting part of the solution.
Yeah, so I mean, in the grand scheme of things, it's a little bit of a lame answer, but the liquid cooling solution or cooling solution in general that you pick depends a lot on either environment, data center, infrastructure already in place or that can be put in place. Clearly, the overall trend is toward liquid cooling technologies to manage heat, but there are infrastructure requirements tied to most solutions that need to be factored in and aren't always possible in every data center. Also, just because you can cool something doesn't mean you can power it. And we've run into situations where even the floor weight limit is the limiting factor. So at a high level, your cooling solutions can typically start with something like a rear door heat exchanger or a liquid to air rack from somebody like Vertiv. Then you have DLC, which you can get in either single or dual phase. Again, the Evidence solution is unique here in their approach to cooling all the components within the rack. And then you have immersion options, which also come in single or dual phase. We see much more interest in single phase in that space. It can be very efficient, but there are warranty and maintenance issues to consider there. So in case all of that feels a little bit like juggling mud, liquid cooling is coming on very strong, and it's something where you want a solid partner that not only understands your compute, networking, and storage needs, but also your data center environment.
Yeah, it's funny. I guess I'm getting old. I remember when somebody proposed that a rack was a kilowatt, right? And we were like, "Oh, that's like so much, right?"
That's not even a GPU anymore, right?
Yeah. It's like a whole kilowatt. How are you going to get that power out of there?
Yeah, we're moving into to 1.2 kilowatts per GPU here pretty soon. It's wild. So liquid cooling is going to be a reality for most of these, especially dense environments. But again, taking that holistic design approach is important because you can't just control for only heat dissipation. It's also, can you power that to a rack? Can you drop a megawatt or more per rack? We're getting there. So
what's the limit? What's the limit where because I've heard that essentially there's some number and nobody agrees what it is, but there's some number of amount of power per rack where you just have to go to liquid, right? You can't use air anymore.
Yeah, that's a great question. And again, it depends partially on data center, right? So how cold is your data center? Do you have a hot cold aisle set up? But we're seeing pretty much anything moving beyond 40 to 50 kW per rack is almost going to liquid cooled. And you can get like,
oh my God.
It's but I mean, there's caveats there, right? It's the same thing when you're designing a server and how many of these GPUs can I stuff in, and then what's my TDP limit on my CPUs? Again, what can you set fans to? What's your ambient temperature in the data center? What's your exhaust strategy? I think that what's nice is there are kind of scaling options, so you don't have to jump into something like an AI 1200H to begin, where you're able to do 250 kW in a rack. You can do a rear door heat exchanger or a liquid to air rack, which starts you off around 70 kW per rack. That can cool. So there's scaling options there.
That is big numbers.
Yeah, no, it's a lot. It's an expensive power bill to be sure. So. That's why we look at all that's going on with nuclear right now. They're starting out in 3 Mile Island again, and so power is another one of those tent poles. And it seems like power is kind of the toughest thing to chase right now, especially when scouting data centers. Finding available power is tricky. So unless you're a
we'll see. Right? There was a huge move away from nuclear after Fukushima, and
yep.
By the numbers, I just don't believe it. I think the nuclear is if you just look at the, unless we figure out cold fusion, you're going to have something like that.
Yeah. Yeah, it's well, and you've got, kind of miniature, modular options now, and but do you really want to be starting up diesel generators to to run all this? Or your coal fire plant, or so if you want it to be clean, you've got to go with some kind of safe nuclear option. And it seems like that's where most of the investment dollars are flowing.
Interesting. So, as the solution provider, right, you guys have to think about the whole system. We think about storage, and we think a lot about balance in the storage, right? How do you
Yeah.
balance the performance layer with the value layer, et cetera? How do you see that at the system level? And, how do the components like VDURA's, factor into that?
Yeah, I mean, so no lie, I took a customer call a couple of months ago, and they had a $300,000 GPU box, and they connected it to a 1 gig network, and they daisy chained some consumer NAS boxes that you can buy off Amazon, right? And they're like, my performance is terrible. You don't say, right? Like how are you feeding your box? And then they wanted to scale to a cluster, right? They wanted to cluster these compute nodes, but they didn't have any budget left for network or storage. And look, I get that, in the age of, multiple chat GPT moments. I mean, look, we got, Manus AI, the new agentic AI, and look, the sexy money is on compute, and that's where a lot of dollars are flowing. If you are not considering the network and the storage piece, you're tying your own shoelaces together. So that's what we really have to consider, along with the infrastructure. We can't just go stick this in a data closet somewhere. So as we're moving to an era where today you can have multiple, hundreds of kilowatts per rack, in the right environment, there's just no way to go stuff this under your desk. You can play with something like NVIDIA digits. That's great. But for something that's truly scalable and going to grow and do any kind of training workload, you've got to factor in kind of an end-to-end approach.
I first started working on HPC. Somebody told me, they said, anybody who really figures this market out realizes that HPC is not a compute problem. It's a networking and storage problem. And
100%.
you got to be good at those. How do
And
you
networking is
see?
one of the hardest pieces, right?
Yeah, oh, absolutely. Just kind of on that same thread, how do you see the transition from like pilot AI projects to full scale deployments? Because not only are people kind of having this new workload, but also that world is changing from kind of the science project world to people are actually using that world. Like, how do you see that, and how does your solution fit into that?
Yeah, I think there's a lot of uncertainty, and everybody, there's calls I've taken where, hey, our CTO says we have to do AI. I said, well, what do you mean you have to do AI? What are you trying to accomplish? What's your goal? And I think we're pretty quickly moving from, just the blank screen chatbot phase, and then you start looking at agentic AI, and like this is rapidly accelerating. It's going to fundamentally change people's workflows.
Oh yeah, what could possibly go wrong too, right?
What could possibly happen? Who hasn't seen Terminator, right? But I think that this is the biggest change that we've seen in this industry in a long time, and it's moving so rapidly, and it's exponential, right? The more it happens, the more it happens, and it's just taking off so rapidly. But I do see, there were a lot of organizations that tried to jump in and just throw money at the problem, and time to market was more important than what they were spending. But I think once you start seeing this move into the business application space, the user space, you start seeing, you hear about the balance between training and inference, right? As you
Mhm.
move more towards that inference piece and the need to actually make a business case for it, you're not just going to be able to throw money at it forever. Not most organizations aren't an OpenAI who's pulling billions of dollars of investment and can operate at a loss for however long. So you have to pretty quickly make a business justification for why you're doing what you're doing. And we always try to take an approach where we can start off with something like Atlas AI Ignite. We can put together, you can start it as a POC, but then you can scale it up and out to a full production environment. So you're not just taking some dead end POC approach. And we view that as kind of an important, design philosophy, that you're always able to scale from a POC to production environment. And if you know what you're doing, and you've got a large need, and you need something like, the full-blown SuperPod factory, we can deploy that as well and just start at that point. What are
Yes. Oh,
oh, go ahead.
I was going to say, our storage solution works the same, right? We have this, a couple of boxes that kind of get you started, and then that can turn into a full blown system that you can use the same hardware and just scale it out, to match.
Yeah, no, I mean, that's what we love about your platform, the ability to, mix and match the flash and spinner. It's unique in this space. And you can really match the storage to the workload, which you don't always see. It's a lot of times it's either slow storage trying to catch up, or it's too much flash, and then you've paid for a lot of flash you don't necessarily need. So being able to match the storage to the workload is absolutely key. On that, what are you hearing right now on the balance between on-prem, hybrid, and cloud environments?
Well, that's a really good question. Kind of the two things I think about probably the most are that one, and also the kind of the right mix of flash and HDDs in a system. And so it's funny, about 10 years ago, my background, I had kind of double-digit years at AMD designing CPUs, and then running their embedded business and consumer, and then I had another double-digit years at Seagate. And I had a chance to work with the big 10 clouds kind of as they were just coming up, right? So I've spent a ton of time with, you can name them, right? Between America and China, there's some really, really interesting products out there. And it occurred to me at some point, it's like, oh my gosh, every cloud's going to be a hybrid cloud, right? This whole idea of, it's kind of a false question. Is it on-prem? Is it in the cloud? It's really going to be, it's going to go back and forth. And, there's such an interesting dynamic with the AI world because, essentially just due to scarcity, either in price or in availability, people have gone to the cloud for their training, not because it's the most cost efficient thing, but just because the only way they can get access to the GPUs, right? Or they, or they just can't afford them, et cetera. And so you have clearly this population of customers that are just using the cloud out of necessity, right? And they probably will, many of them will just continue for a long time. But then also, another element we see is kind of the maturity. So, we have a lot of customers who are, you would call traditional HPC customers, which again feels a heck of a lot like machine learning AI to me, but they're very efficient. You think about the teams have been working sometimes for decades, together, and they're really good at maximizing the use of the hardware, really maximizing the hours of the cluster that they're doing, and then you get this new Gen AI world where everybody's just throwing everything at everything, and it's going nuts. To my mind, that has to mature out, right? It has to become more mature as people, because again, it's like $1 billion here, $1 billion there. Pretty soon you're talking about real money, right? It's like people just can't afford to do this, and so then they're going to be thinking, all right, well, I'm spending this much in the cloud. I think maybe I should look at an on-prem deployment just because of cost, right? And so I think that you'll see this back and forth happen forever. Right. So, that's one of the big engineering investments that our team did when we, first started was this, we really need to take this stack, which is, one of the most mature and well thought of high performance stacks in the industry. We really need to port it to microservices so that we have the flexibility to run in one or the other. And that's essentially what we've done there. So we've completed that now. And, we have a fully microservice based architecture, and that gives us flexibility to work either on-prem or in the cloud.
That's fantastic. What do you see around data gravity? So obviously, it's free to get in. Egress costs you an arm and a leg in a lot of these cases. So, and particularly around, AI and HPC workloads, those are pretty heavy on the storage side. So for those who have started maybe in cloud, what's your route to on-prem once they've kind of formalized what their production workload looks like and they want to maybe repatriate some of that back on-prem?
Well, I think you said the important thing right in the question, which is the data is the thing with the gravity, right? When I worked at AMD, which is a great company, I loved them. I thought that the compute had the gravity, but then I ended up in the storage world. I'm like, oh my gosh, that's not true at all, right? It's easy to spin up a compute cluster in somewhere next to a waterfall or something like that where there's cheap power, but good luck moving a petabyte of data, right? That is just super hard, and that's, I think, the biggest barrier for people moving back and forth. And it's not just the cost. It's just like it takes a ton of time and bandwidth to move a big chunk of data.
Why do you have something like Snowball, right? You just can't move it all over the wild. especially at a certain point, it just gets very difficult. And then how long do you shut off operations to transfer it? It's tricky. So
Oh yeah, there's an aphorism that's like the highest bandwidth connection in the world is a UPS truck full of data tapes, driving down the highway because you
yeah,
just can't
yeah,
move anything else. But
for
I
sure.
think that's one of the things that people are really going to have to plan for up front because it is quite difficult to to move your data once there, and that's one of the reasons that people will stay with wherever they are. But I think ultimately it's a cost question, and if you're doing this, especially if you're doing deployment at scale, not so much the pilot projects or the inference. I think that you just the dollars are going to drive you to have some kind of solution strategy. And the other thing that we shouldn't miss is people really don't want to put their data on the internet. This new DeepSeek thing came out, and I tried it. It was really cool. And I realized that everything I'm sending, putting into that tool is going right to the
You're
somebody
trained.
in China, and maybe that's okay, but like maybe not. And I, certainly if I'm that's just like me asking for advice about where to watch the basketball game, right? No company's going to want to do that, right? They're going to want to have their data where they can see it.
For sure. I mean, you think about, why was Facebook free, right? Well, you gave it all your data.
Yeah, yeah,
You know,
yeah. It wasn't a product
very,
for you. You were a product for it.
yeah, exactly. So if you're looking around, if it doesn't cost you anything, you are the product, right?
Yeah.
And so that's, I think a definitely concern. Look, we work with a lot of, like DoD and IC and FSI customers, and a lot of those guys can't put things in the cloud, or you can put something in the Gov cloud maybe, but do they have the right, compute and storage instance for your workload? And a lot of these organizations, want to own that. So we've certainly seen a lot of repatriation. There's that big shift to cloud. We've seen a lot of repatriation, back to on-prem.
Mhm.
But particularly around long-term established workloads, budget's usually predefined for those. There's the joke of, like, why are you bankrupt? And it's like, I left my GPU instance on over the weekend. Uh, and so, now my program's shut down. I've got no more grant funding. I accidentally spent it all because we just left it on during peak hours. Um,
Whoops.
but anything, high utilization, high performance, great use case for on-prem. And then we're seeing cloud leverage more and more either in the POC space, or again, because hey, it's been tough to get GPUs. Can you get a cluster of the right size to actually, run a reasonable test workload? So anywhere there's resources. So cloud's a resources play in a lot of respects. Bursting, seasonal workloads, et
Yeah.
cetera. But I think, to your point, I think every environment's a hybrid environment. I can't point to one customer who's running just on-prem or just cloud. I think it's about striking the right balance, but really thinking about where that data needs to live in advance. It's a critical aspect because that is so hard to move once you're entrenched and generating more and more data.
Yeah, it's the data's where the gravity is. One of the questions came in from the field is, what about data integrity and how do you protect your customers' data? That is something, especially coming from a device manufacturer for 12-ish years. Like the first rule is do not lose your customers' data, right? That is the first rule and this data, think how valuable it is. Not only is the core training data just incredibly valuable. In fact, it's the main asset in a lot of companies nowadays. That's a big change, by the way. Nobody could say that 10 years ago, right? Or hardly anybody.
Right.
Now it's true all over the place. And architecturally, that's something we've put a lot of energy into. And we have an architecture in the VDURA product that is really designed to treat your data really well. And we essentially have a scale out architecture. So the more nodes you add, the wider the stripe you can protect. And we'll do erasure coding across the nodes. And we also have technology nobody else has, where we can do erasure coding inside the nodes. So we do dual level erasure coding, just like the big clouds. And we'll get as much as 11 nines of data durability for our customer. And so that's we've been able to do that. We also realize that not all data is the same, and that's why we've implemented a feature that's unique to us, where you can choose at the file level how much to protect your data. So if you've got very valuable data, give it the maximum level of protection. If you've got data that is not as valuable, give it the least cost option. And we give the system the ability to have those data sets live in the same system.
Yeah, I think that's key, and I'd really like you to highlight, what's your minimum protection level, And then, and you can obviously scale it to 11 nines, which is hyperscaler level, right? Which I can't name another storage product that has that level of protection and durability. So what would your minimum protection level be at a base deployment and out through the 11 nines?
Right. So minimum would be 4.2, and that's rough. That's between 3 and 4 nines, depending on the architecture. And that's that's as far as a lot of these like NAS go. Right. That's where they end. That's where we start, and then like so we go all the way up to 11 nines on the disk and 12 nines in the flash. Right. So you can have just an incredible level of protection, because again, that's the background is like the first rule is do not lose your customer's data. The second rule is do not annoy your customer. Like let your storage system be easy to use, and that's the other thing that we've really focused on is kind of this enterprise level of just turn it on and it works, and you don't have to mess around with it. And that's something that's actually unique in the world of high performance storage.
Oh, absolutely it is. I mean, there's a lot of science projects out there, and especially if you're coming from the HPC space, where so much is tied to open source, which is fantastic. But if you're looking at something at, for mission critical or national lab level, you can't afford to lose that data. In a lot of those circumstances, there's, if you want an RFP there's a penalty tied to any kind of downtime, outage, data loss. So those become just critical elements. And, we kind of have this motto of, never ship your customer a box of parts.
That's great.
I mean, nobody wants that, right? They don't want the bike to show up unassembled and have to build it before they can ride it. That's not fun on Christmas morning.
Like you're not the IKEA model of solution provider.
I mean, look, if you really want that, like, you let us know and we can do something special and ship you parts. Like, if you want to say I built it myself, I'm MacGyver. But we want a state where we can deploy a full stack solution, compute, networking, storage. It rolls into your data center. If you want white glove service, you want our engineers to come on site, set it up. It plugs into network and power, and you're up and running. Because as I said earlier, as we move past the stage where organizations are just given blank checks to pursue AI and they start having actual business outcomes tied to what they're doing with it, it's very important that they're not sitting there looking at a manual upside down for the first 90 days saying, what do I do with this? How do I use it? They need to get up and running. So whether that's getting the right stack in place, whether that's preloading with a suite of LLMs, whether that's some pre-tuning to have you up and ready, and then a knowledge transfer session, all of those are important to be able to offer, so that you're not just kind of dropping somebody in the middle of the woods and saying find your way out. It's just not fair to do.
Well, that's just something I appreciate. As you know, I've worked with SourceCode for years and years now, and that is just one of the best things about your organization is that you never leave your customers without the working solution. And I really appreciate it, and it's something that really distinguishes you from everybody else.
Yeah, no, I appreciate that. Hey, we kind of touched on it earlier, and I wanted to make sure we circled back. So with AI workloads, how do you look at different types of storage technologies like all flash or hybrid in the AI environment?
Well, thanks for bringing that back up. Like I said, that's something I've spent a ton of time on in my career, and there's a real there's a real pull to just use flash for everything. And by the way, that would be the easiest thing for us, right? Flash is easier to manage. You got great IOPS in every device, et cetera, and it's great. The problem is that it's expensive, right? And I had an analyst tell me the other day, well, after some number of petabytes, the flash costs the same at the system level. I'm like, no, it doesn't. It's not even close. And like I said, I've watched this really closely. Here's the bottom line is that depending on what month we're in, flash costs 10 times as much as a disk, on a per byte level. Or maybe it's been as low as 4, but that was kind of artificial after COVID. Right now it's at like 7.8. It was about 8.4. Like it keeps moving around. And, ultimately, if you look at the technology, the flash manufacturers are at QLC, the disk manufacturers are now using these lasers to heat up a billionth of a square meter of the disk surface for a billionth of a second to write it, the mosaic drives. They're getting bigger. They're both getting bigger, right? And we see for the foreseeable future, kind of this 7-8x delta between the media. And then, of course, at a system level, it's not exactly that much, but at scale, it's exactly that much, right? And that's why you see all the big clouds. Like I said, I have this significant experience with the big clouds. They're all at 5 to 8%, 5 to 9% flash, just because that's the most efficient. So, ultimately, back to the don't annoy your customer, don't decide for your customer. So what our architecture, we handle both, right? We've got these hybrid nodes with spinning disk and flash. We've got all flash nodes. We'd love to sell you an all flash system. We'd love to sell you a fully hybrid system. And by the way, you don't have to decide today, right? You can buy a little system, and as you grow, you can either add inexpensive disk or fast flash, and they live together very nicely. So, ultimately our strategy has been, don't make the customer decide up front. There's no reason for it. Support everything. And then, as the workloads change and as the market goes up and down and the delta between those two move, we've got you covered. And that's something that's really important to us to maintain.
Yeah, no, I think that's critically important. One, there's customers who get pushed into an all flash solution because that's all the vendor sells, or there's customers who get pushed into a disk-based solution. Hey, you don't need flash because that's all the fact that you do both and can do either all flash, hybrid, it's unique, and it leads to a lot more trust in the solution that, hey, you're not just getting pushed something because that's all I have to sell. If all I have to sell is fish, you're eating.
Yeah.
Right?
You get a hammer, everything looks like a nail, right?
Yeah. I want a steak, damn it. So I think that's critically important. I think the other key piece there is you guys have mapped so well to what the big hyperscalers are doing, but you're able to scale it down to even a POC level. So you've got the kind of the full spectrum of what you're able to do, but you've mapped your architecture to what the hyperscalers are doing. So from, even like, because you have to think about not just, hey, can I deploy it? You have to think about supply chain. Well, where's all the supply chain going in terms of, flash and disk, right? And you've mapped your architecture to that same supply chain as the hyperscalers, means that pricing is going to be better. Availability is going to be better. You're not off chasing, a SAS SSD that's, like the bane of everyone's existence.
Yeah, every process generation now, the delta gets wider between kind of the legacy enterprise devices and the hyperscale devices, and we're able to consume those hyperscale devices natively, and so it's a bigger and bigger advantage every time I look at the next product.
Yeah, no, it's a key differentiator, to be sure. Do we want to launch into some Q&A here? I see we have a couple of questions come through the chat. We can talk about San Diego.
Sure. You're done before. That's where I'm from. That's where I grew up, and I'm going to visit this weekend. Well, one of the questions, Matt, what verticals or use cases do you see the most growth in AI installations? What do you think?
Oh God, I mean, that's a great question. I think overall we're going to see it everywhere. It's going to explode everywhere. We're seeing a lot in the commercial space. So SourceCode kind of divides itself into three big, we call them more horizontals and verticals, but we have commercial, we have EDU research, and then we have Fed, DoD, those guys. So commercial has been kind of the canary in the coal mine for a lot of this, because a lot of those customers have been able to get online, access those tools. They haven't been shut down by their organizations. Guys like Fed have kind of lagged a little bit in terms of access to tools like a ChatGPT, for instance. But there's a lot more in the area of like air gap solutions that you can deploy now, where organizational data can be kept safe. But then arming those organizations with tools to be able to engage with the latest technology. So we're seeing things even out of DoD and the intelligence community. Financial services is starting to come on in a big way. There's a ton of value there, and if you look at some of these deep research models, the amount of work that they're able to produce in a short period of time is really incredible.
It's astounding, and it blows me away.
I mean, I heard somebody say they had they did a stock analysis with this new with the new Manus AI agent, right? And that's out of China, and it's China's. Well, some have called it the next DeepSeek. Some have called it the next like ChatGPT moment. And they've given it they did a stock analysis on like Tesla stock. Which, I mean, it's like tracking a rock falling, right? It's been a lot of red, but but they did a stock analysis and they're like, listen, this would have taken my, my PhD grad, 2 weeks to do, and it did it in an hour. And it's, and they would check through, they're like, it's accurate. So it's really incredible the amount and the quality of work that can be done in such a short period of time.
Yeah, there is no industry, no part of our lives that I can see that will not be somehow touched by this technology and the change in this, what we can do.
Unless you mostly use Siri for the next year. That's lagging a little bit behind. But you look at even like Alexa Plus, it's going to start touching everyone.
Yeah.
My wife and I are booking a trip. The kids, we're headed down to Cabo. My wife is cursing from the next room. She's like, I'm trying to manage flights, and you've got miles on all these different airlines, and I'm trying to, get tickets. I was like, what's going to be really cool is, hey, link to all my accounts. Hey, here's what I'm trying to do, and have an agent do that for you instead of my wife pulling her hair out and cursing me for flying different airlines, right? So I think that consumer space, it's just going to be, my kids are already cheating on homework with it, so I've got to watch that. But
I had this hilarious Uber ride to the airport the other day where the Uber driver's telling me this story where he's driving an attorney, right, a lawyer,
yeah.
And the lawyer's like, what are you going to do after there's self-driving cars? And the Uber driver's telling me, he's like, driving a car is hard, but being an attorney is easy if I got ChatGPT. Like that guy's the one out of a job. I mean, it's just amazing.
Don't tell our general counsel. Start evaluating reseller agreements with with Claude, and it's really incredible.
How are you doing on time, Matt? Do we have time for another?
Yeah, I've got time. For you guys, as much as you need.
Cool. So how do you look at the future with more optimized models, larger RAM and GPUs, and faster networking? All this will put greater stress on the storage system checkpointing.
Hey, that's for you.
Yeah. Well. So it's funny. We're a true parallel file system, right? So you have a lot of agents, doing something in parallel. You get a lot of performance. Now, there have been some other vendors who do not have a parallel file system, and they've argued very strongly that you do not need one because they do not have one. And here's the thing, it's a physics problem. Ultimately, the reason that the industry created a parallel file system is because you have these really expensive compute farms and they run for a little while and then they stop and they checkpoint and nothing's happening during that checkpoint, right? The checkpoint, all those expensive GPUs are just sitting there. So you want the checkpoint to happen as fast as possible. So ultimately it is an amount of bandwidth, right? Times a number of devices that can handle that bandwidth in parallel. So you can solve the problem however you want, but it's still a physics problem. And that's something that we address just so well with our architecture, because the way it works is that we essentially have a scalar architecture, just like a hyperscale cloud, as you mentioned. So we can just keep adding nodes. And every time you add a node, you almost completely linearly increase your IOPS, increase your throughput, et cetera. And so you want a faster system, just add some more nodes. And it just keeps going. So that's something that we are really well able to address with our product.
Yeah, I mean, obviously, a scale-up architecture couldn't accomplish the same feat, and we've seen kind of the scaling limits of that, for years. And so, having a true parallel file system is critical. I mean, look, the compute workloads are parallel, so you're already computing in parallel. Why wouldn't you have a storage system to match? And then, also key there is the ability to leverage, high bandwidth networks. And, your support of both Ethernet and InfiniBand is crucial there, because if you're snapping into like an HPC environment where IB is the standard, you're able to tackle that. And, if you look at more of these kind of these AI or training architectures where things are much more heavily weighted towards Ethernet, you're supporting that natively. So, it's about matching up the right technologies together.
Yeah, it's funny. I was looking at all the bids we're doing for our new product, the V5000, and I was hoping that it would be dominantly one or the other, and then I could focus the development. But I'll tell you, it's right down the middle. It's like 50-50, depending on what vertical they do, either Ethernet or InfiniBand. And the other thing is we're thinking about the next generation. We joined the board of the Ultra Ethernet consortium. I think that's an interesting Ultra is an interesting future. But ultimately you have to keep up, right? You have to be able to keep up in the performance of the storage system. You have to keep up in the networking. Everything's got to be able to keep up with those GPUs, and it's got to be easy and it's got to be reliable.
Yeah, no, I love that you guys are part of the UEC. I think it's a critically important development in the industry. I mean, look, Ethernet's there on bandwidth. It's a latency issue. And so the UEC trying to flatten that stack and reduce latency to be closer to IB is very important to the progress being made. I think that's I think it's fantastic. We had a question come in. What type of performance can we expect, and can you scale to meet the ever-increasing AI workloads?
Oh, that must have been one of our people that wrote that, because that's such a softball for VDURA. We scale linearly, we scale out. So the more nodes you add, the more performance you get. And we have a key value store, Chris, that keeps track of everything. We think we have the world's fastest key value store, and it is not uncommon now for us to be talking to customers about terabits a second of system performance, right? So 1, 2, 3, 4 terabits a second kind of performance. And of course, that is our wheelhouse, right? Thousands of clients, terabits a second. That's high performance. That is where a parallel file system just shines bright. And so it's a really, really good world for us.
Yeah, no, that's that had to have come from Brad. It was in the employee handbook. No, that scaling is key. But again, and why we leverage you guys even for the Atlas AI Ignite is because you can start at that POC stage, right? You can scale it down to a level that's very impressive, and you're still getting a minimum of 3 nines of durability. But then scaling that to full-blown production is really unlike anything else we're seeing in the market right now.
Cool, Matt, it has been a pleasure talking with you today. Thank you so much for your time.
Hey, thanks so much for having me. Anytime. Take care.
Cheers. Bye.